Hey guys, welcome back. So today we're working on this 5500 watt storm responder generator. These machines are fairly simple and well made and should last a long time. But starting in 2006, Briggs omitted the oil sensor. So you do have to check the oil, and as long as you keep oil in the engine, you should get many years out of this machine. And unfortunately, not everyone checks the oil. And I've fixed quite a few of these that ran out. And this one I haven't checked the oil yet, but given the engine is locked up, I would say likely this one was also run out of oil. So the goal today is going to be to get this machine up and running again. So let me get you set up a little bit better and get going on this. All right, so first things first, let's see if we have any oil and the cap is actually loose, which is not a good sign. And surprisingly, we do have oil in the engine. Let me get you in there and show you. So there's a look at the oil. The oil actually looks pretty clean and almost full. So it would appear that this machine did not run out of oil. So on the surface, that would appear to be a good sign. But what often happens is that, the engine locks up or starts making bad noises, so someone shuts it down, sees that there's no oil, they top it off, but at that point, the damage is already done. But, let's give this one the benefit of the doubt. I'm thinking let's actually pull the tank out of the way. I do want to get the blower housing off so we can get a wrench on the flywheel nut and see if we can get this engine to rotate. That tank's actually pretty full. I would say a good 3 gallons in there, about 10 liters. And we also have a critter nest, which hopefully nobody's home. So, I do want to get this heat shield off. Really, this is just going to give us a lot better access to, the top cover we need to remove, as well as the blower housing. So I'm going to get this removed, just 4 bolts going around and a couple down by the exhaust. And this should lift right out of the way. All right, looks like nobody's home. Did cause a bit of corrosion, but could be a lot worse. So we need to get this off first. Just 2 bolts right there, a couple on the front. This will lift off, and some wires for the switch we will disconnect. Now, this gives me a little bit of hope because that mouse nest was kind of right above the cylinder head. You can see there is some corrosion here, and the carburetor is actually missing. So there is a chance that this engine issue might be a stuck valve, or maybe the piston and rings are stuck to the cylinder wall. That's kind of best case scenario, but let's keep going. Yeah, definitely signs of a critter. And actually, when I pulled this cover off, an acorn fell on the ground. And you can see the fins are also pretty clogged up, at least down here. So yeah, a lot of corrosion right here. So I'm guessing there was a nest right here that maybe somebody cleaned out. Although as I say it, I'm looking down here and I can see more nesting material. So we might have a much bigger nest, you know, in the blower housing. Anyway, let's get these wires unplugged and removed and set this off to the side. So the actual airbox metal looks good. So I don't think the critter actually made it in there, but we are missing the front of the airbox, you know, as well as the carburetor. Anyway, to get this off, there's just two 10mm bolts on the right side. And then tucked in here, we actually have a fastener that requires a Torx socket. In case you're wondering, it's an E5 Torx socket. And I just broke the bolt off. Right at the tip where the Torx attaches, so that is not a good thing. So that's the stud right there, just the tip broke off, which has the part for the Torx socket. So we can probably double nut and get that off, but we need to get better access to it first. So we'll pull off the airbox as well as this right here, which, you know, technically these really shouldn't be on the machine. They ship with it installed, but the purpose of this is to recycle hot air coming off the head right into the airbox. So this is good for, you know, winter operation where it's below freezing, but in normal conditions, you don't need this. And it's actually going to run the engine hotter, you know, likely consume oil faster and lock up the engine. So if you have one of these on your machine, I would definitely pull this off and only put it on if you're running in below freezing temperatures. Those are both on there pretty loose. All right, so we need to thread two nuts on here. These are an M6 1.0. And unfortunately, the only ones I have for this are the nylock locking nuts. So we need to actually drive this down most of the way. We'll put a second one on, tighten the nuts up against each other, and then it should lock onto the threads. And with any luck, we can back that stud out. All right, so I'm going to lock those two together, but before I do that, I'm actually going to strike the stud and the housing with a brass drift just to try to break, you know, some of the corrosion between the bolt and the stud, hopefully releasing the stud. Now, I'm just spinning the nuts and likely stripping the threads on the stud. So I'm going to try a little bit of heat. Got to be careful though. I don't want to set Fluffy's nest on fire. Nope, that is pretty stuck. So I've been working at this unsuccessfully for quite some time. I'm tempted just to cut the bolt off. This engine is likely bad, but given the evidence of the mouse damage, I'm willing to bet there is a reasonable chance that it's not actually bad. So we might cut it off anyway. But I think I'm going to keep working at it, see if I can make any progress here. Look at that. It's turning. A lot of rust up here. Okay. Bolt has a lot of corrosion. Time for the big reveal. Wow. That is quite a nest. So yeah, definitely a critter made this his home. And you can see it's just packed in right on top of the coil. So there's actually a very good chance that the flywheel might be rusted to the coil. So let's get this nesting material out of here and see if that is the problem. And hopefully nobody's home. Wow, it is just packed in there so deep. And the kill wire was chewed. There's actually a little bit of bare wire. So that has to be replaced. Likely the coil as well. But yeah, I think that's our problem. The coil seems like it's rusted to the flywheel, at least right here. So let's see if we can get this coil free and just off the machine. And then with any luck, the engine will rotate. So I'm going to do this one by hand. These bolts, under the best of circumstances, they're very thin, and they don't take a lot to break. Yeah, I'm not liking the feeling on either of those. Nope. Okay, we got the bottom one. Okay. So does the engine rotate? Yes, it does. Not very well. So there is some stuff packed behind here. You know, potentially there's some corrosion in the cylinder as well. So I'm going to pull the plug, get some penetrating oil in there before we try to rotate this anymore. Yeah, I think there's a combination of problems going on here. Some of the resistance is the stuff behind the flywheel, but I think there was also a stuck valve. At least the intake was stuck. I can see that it's moving now. And we've got another tight spot right here that we're now through. Although it doesn't sound great in there. But it looks like we are rotating pretty well. And you can just see all the debris falling out from behind the flywheel. So I think some of that, yeah, I think there might be some more nuts back there causing things to hang up periodically. So yeah, this engine might run. Got my hand over the spark plug hole. And there is compression. So that is good. That means this engine is not blown up. It will run, but obviously it's going to need a bit of work. So I usually don't like pressure washing generators, but this one I'm going to make an exception for. So I'm going to get this tin off on the top that has all this debris in here, and we'll plug up some of the areas we don't want water. And then I'm going to bring this outside and get this thing somewhat presentable. So get the coil out of the way. Spark plug is back in. And I'm also going to remove this governor linkage. Likely the pressure washer is going to blow that off. And I guess we should get this tin off as well. So that bolt, similar to the ones that hold the coil on, it's a very small bolt, so we're going to have to proceed cautiously. All right, so that cap is nice and tight. The intake I blocked with a piece of rubber from a tube and just sandwiched it using the insulator. We've also capped off the breather, so the engine theoretically is sealed. So I'm going to start just by using the leaf blower to blow off some of this loose debris. And then I'm going to give this a hot water bath. I recently fixed this pressure washer for my friend, and he hasn't been able to pick it up yet. He's actually kind of in the process of moving, and he asked that I hold on to this for a while. So we'll get this fired up and get the machine over there as clean as we can. All right, so I'm going to give this a bit of time to fully dry before, putting it together enough to start. Now, while it's drying, I am actually going to make a trip to the storage locker. I do have a lot of parts for these 10-horse Briggs engines because they typically do run out of oil. So we need, obviously, a new coil. The carburetor's missing. The airbox is mostly missing, so I think I have all those parts. Cooling fan has a bit of damage. And, likely I have some of these other parts that are corroded that need to be replaced as well. And maybe a new blower housing. The one that's on there could be used, but there is a lot of corrosion on the backside. And likely I already have all the parts needed, just sitting there doing nothing. So let's get those parts out and see if we can improve a bit on the appearance of this machine. All right, so I did find a few things here on hand, starting with an engine mount. The one on the mouse side, it's corroded pretty bad, so we'll get a new used one of those installed. We do have a complete airbox, a new tin for the cylinder head. The one that was on there was corroded. We do have some OEM Nicky carbs, condition unknown, so likely we're going to have to go through those, and a used known good coil. And I also dug up some hardware like the studs to hold the carb in place, a new bolt to replace that one that gave us so much trouble, and some other miscellaneous hardware. So let's make a trip to the storage locker and find the rest of the parts we need. So we made out pretty well at the storage locker. I came up with 2 recoils. Either one could be used to replace the original. And I also found a heat shield that is dirty, but not corroded. So that'll clean up quite well. But there were 2 parts I was hoping to find, which I did not. The first one is this metal plate right here. And the more important one is the fan. I think this fan should be replaced, potentially the flywheel as well. So we do have another option for that. And that would be this machine over here. This is obviously another storm responder, slightly different model. This one absolutely has a blown engine. It just freewheels. I do not hear the piston going up and down. So potentially that could be rebuilt at some point. But for now, I'm thinking we just harvest the parts that we need. And the parts, they are a little different. The blower housing is different. We don't have the plastic piece. And we actually don't have that rusted plate. The switch just bolts right to the engine. So I'm pretty sure these parts can be used, as well as the fan. And I'm thinking we should probably move the flywheel over as well. So I'm going to get this up on the lift. We'll harvest the parts we need and get the other machine back together. So we do need to get the airbox off and at least loosen the carb up before we can get the blower housing removed. And I'm probably going to take this carb off completely, just in case we need it on the other machine. So at this point, I think I've pulled pretty much everything I need to make that other engine complete. I did also pull the exhaust. The exhaust on here looked virtually new. And for the record, this engine definitely ran out of oil. So there will be a video on this one at some point, but that is not the focus today. So I'm going to get this machine off the lift. We'll get the other one back up on it and start putting it together. All right, so we get the better flywheel on, although it's kind of relative. Get the key in place. So this is the starter cup that came on the machine, and this is the starter cup that's coming from the parts machine. I think you can probably see this one's a little bit taller, and likely it's needed for the blower housing that we're going to use. And we are going to have to adjust the engine speed a bit, 'cause the plate I'm putting on, likely it's not exactly the same bend, so the spring tension is going to be a little different than it was with the original plate. No, this is not going to work out. So the holes, or the mounting locations, they're further apart on this older version engine, whereas the newer one that I pulled this from, they're closer together. So we can't use this. This is in the wrong position. So we're going to have to use the rusty plate the original starter cup and the original style blower housing. So I'm going to pause it, get that plate reinstalled as well as the original cup, and then we can move on. Okay, so we get the original bracket back on as well as the starter cup. Yeah, everything's been retorqued. So the coil would probably be the next logical step, but we have pretty good access to this rusted mount. You know, the one on the other side looks to be in great shape. This one not so much, and I do have replacements for this. So this bolt that holds the mount to the engine is actually one of the bolts that also holds the exhaust in place. So this one, although it's not bad, you know, the one from the other machine is better. So I'm going to swap this out while we're at it. All right, I'm going to leave these a little bit loose for now. You know, we need to get this bracket mounted. So let's replace the engine mount first. We'll snug those bolts up and then torque the bolts down. So I'm just going to knock the surface rust off the flywheel. The rust itself isn't going to cause any spark problems, but it could prevent you from gapping the coil properly. And even if you do, the coil might contact the flywheel if you have some raised rust. So I'm just going to go around the flywheel, just make sure there's nothing sticking up too far. And then we'll get the coil installed and gapped to 0.010 of an inch. So rotate it once around, just make sure there's no contact between the coil and the flywheel. It looks like we're good. And we'll just snug those up a bit. Okay. All right, so before we get the blower housing on, let's just test for spark real quick. I'm going to spin the engine over with the drill. Yeah. Hopefully that comes through, but we have nice, strong spark. So the gasket on the back side here looks good enough to test with, but we do need a gasket here. And this is the carb I'm going to go with. It's the cleanest externally of all the ones I have to choose from. The throttle is not stuck, and I tested the needle and seat. It seems to be working. So, yeah, this one I'm going to give a pretty good chance of running the engine. You know, how well? That we will find out. Governor calibration is pretty close. I think we'll be okay. Get that clip on, the anti-surge spring. And we can get probably the spark plug boot in. Get the choke lever on. Okay, needle and seat, they are working. So I think the last thing we need to do here is just add the kill switch back, and we should be ready to give this thing a go. So I'm just going to hook up a switch here temporarily. I'm not going to put the top plastic piece on because we might need to adjust the engine speed. And I'm also going to leave off the airbox. You know, the carb is an unknown. Really, the whole machine's unknown. You know, I don't know if this engine's going to knock. You know, is the generator going to make power? But we will find out in a minute. All right, so let's see if all this time and effort was worth it. We have fuel in the carb, choke is on, ignition's on, we got the kilowatt, and a light. Here goes nothing. Okay, good. So the gamble, I think it paid off. You know, the unknown carb is now a known good carb because the engine started first pull, could turn the choke off right away, and the engine ran perfect. And there was no rod knock, no funny noises. So the engine's good to go. And the generator is also doing well. You know, that light came on right away. Now, there are some adjustments we need to make. You know, the no load engine speed was a little bit high at 63 Hertz, so ideally that would be brought back some. And the voltage, it was high, but that is normal on a machine like this. This does not have an AVR, so there's no automatic voltage regulation. And without a load, usually you see about 127 to 133 volts, and that actually is going to drop by 20 volts under a full load. So we will adjust the spring tension, but I'm going to hold off doing that until we get a more stable fuel supply. So let's finish putting this thing back together, and then we can get it outside and put it to the test. Well, it's definitely earned its oil change. So let's get it changed while it's hot. So I did siphon just a bit out. You know, I don't want it right to the last thread because there is no seal on this cap. And if you fill it right up to the last thread, it is going to drip just a bit. And the oil that came out looks pretty good. You know, there's no evidence of any kind of engine wear or damage, and it does not smell like fuel, so there is no contamination in that oil. So we're just about done. We just need to connect up the fuel line and secure the tank, but I don't quite want to do that yet. You know, this tank is quite full, and the fuel that's in here actually doesn't smell bad, but it doesn't smell good either. There actually isn't much of a smell at all. So there's actually a decent chance that this tank could actually be filled with water. So, you know, regardless, I can't trust it. This machine has clearly been sitting around for a long time. So let's get that fuel out and the tank dried up. It's a good thing we didn't try to use this fuel. You know, the carburetor would not have liked it, and there is no drain on the carburetor. So if this had gotten in there, we would have had problems. Luckily, the water, it is heavier than the fuel, so we can pour off the good fuel and reuse it. But we do need to give it a few days because the fuel, it is hazy, which indicates there is still some water in there that needs to precipitate out. So there's actually a fair amount still left in that tank. So what I've done is just stand the tank up so all the remaining fuel and water are right down here. So I'm just going to use a hand pump to get the last bit out, and then I'm going to mop up what's left. I want to make sure this tank is 100% dry. All right, I think we're pretty much ready to go here. So this generator, it is rated at 5,500 watts. You know, whether it can do it or not, we're about to find out. So I'm going to get the engine started. While it's warming up, we'll double check the output using the kilowatt to measure the frequency and the voltage. We use the amp probe to see what the total harmonic distortion is, and the oscilloscope to see what the output looks like. Then we'll put on about a half load using the load bank. We'll give that some time, and if everything looks good, we'll bring it up to the max of 5,500 watts. Now, this machine might look familiar. This was actually in last week's video where I came up with an alternative to the OEM voltage regulator. You know, this part, it is discontinued, and this is the weak point on these machines. They do need to be replaced occasionally, and without a source of parts, you know, a lot of these machines are going to end up in the trash. So we built an alternative and tested it under a 3,000 watt load last week. The one that we tested is actually still on the machine. And although it did fine, you know, we never pushed it to the max. So I'm leaving it in there just to see how it does. You know, this regulator, it's not an automatic one. So without a load, you know, the OEM part would produce about 130 volts. And under a full load, the voltage drop would be 20 volts to about 110. So, you know, I'm expecting the same behavior out of this. So we'll keep an eye on it and see how it does. So let's get the engine started and see what we get. Yeah, no issues at all getting the machine started. So the voltage without a load is right where I'd expect it. It's at 133 volts. The total harmonic distortion isn't terrible at 7.6, and the sine wave is pretty typical. So let's put on a 2500 watt load. All right, we're at 2500 watts. Engine speed nice and stable. THD is pretty much unchanged at about 8%, and the sine wave cleaned up as well. So we'll give this a few minutes, then we'll go for the max of 5500 watts. All right, no issues at all at 2500 watts. The voltage is holding at 124 volts, and the engine speed is also doing well at just over 60 Hertz. So let's try 3500 watts, 4000, no issues. We'll swap that. So we're back to 4000, 5000, 5500. So the engine's holding just fine. Now at 13.3% THD, and the sine wave a little bit more deformed, but fairly typical on machines like this. So let's give this a few minutes and we'll check back. Well, it's been a few minutes, no issues at all. The engine speed's holding nice and stable, and the voltage dropped as expected by 20 volts. So no issues there. And I would say this engine has power to spare. You know, likely we could go to 6,000 watts, and we can. So let's swap these. We'll bring it back to 6,000. How about 6,500, 7,000? Yeah, it's doing it. It's probably going to pump the circuit breaker if we keep it up. But yeah, the engine definitely up to the task. So we'll take the load off, give the load bank and the engine a few minutes to cool down, and then we'll shut it down. Well, I think we made out pretty well on this one. You know, at the start of the video, we had an engine that was locked up, and I had assumed it had run out of oil. And as we later found, it was actually just held in place by a rodent nest. And once that was cleaned out, the engine began to rotate and had compression. And I would say this engine is in good health because we had no issues pulling 5,500 watts. We actually pulled an overload of 1,500 watts, which actually is a little less because we weren't at 120 volts. but either way, the engine seems to be good to go. And I would say the alternative voltage regulator is also doing a good job. It is behaving exactly like the OEM part. So if you need one of these, I am going to leave a link down in the description as to where you can get one. But for the purposes of this video, I think we're done. So I hope this video helps someone. Thanks for watching.